So moving on to the last case study, cluster effectiveness. This is a big study that we did last year. It's 12 liquids-rich horizontal gas wells in the Montney. 5 wells were done with pinpoint technology, which were the wells most recently spud. 5 were plug and perf, which was what the completion technology they used just before pinpoint. And before they even showed up, there was open hole ball drops in the play. So we had logs, core analysis, frac modeling, and RTA, all integrated for reservoir characterization and completion design understandings. Constrained to all data and information, the cluster effectiveness from this study was revealed that the plug and perfs ranged from 32 to 62% cluster efficiency or effectiveness. Of course, the pinpoint wells were 100% efficient just by the nature of the technology. So let's talk about, these are integrated case studies, and this is, I'm trying to say that they're all slightly different. In this case, the slight difference here is the core analysis that we're bringing in. This was under confining pressure. Of course, under confining pressure is going to lower the permeability from the core analysis, and this is what we believe is the most reflective value for in situ permeability conditions for doing production modeling. Here we can see that the results, permeability results, and these are 18 samples plotted on the x-axis, we're seeing that most of the perm results under confining pressure on the core is around 100 nanodarcies. And this is the basis of using 100 nanodarcies in our decisions for using that as a constraining parameter for modeling. Now also with frac modeling, we did frac modeling both on the plug and perf design and the pinpoint, and here's just an example of a single stage with both methods. Here you can see that on the plug and perf side we're seeing only 2 out of the 3 clusters on a stage are actually effective, and those clusters give fairly different looking frac geometries. One's long and skinny, or one's long and sort of small height, one's a big height, shorter. And one's pinched off, one is stress shadowed right out. This isn't new to anybody here. I'm sure that everybody's very familiar with the countless papers in the literature from all the service companies and many operators that talk about the inefficiencies, lateral stimulation efficiencies of this particular technology. Pinpoint, however, this is, I mean, we're just dealing with 100% stimulation efficiency every time. So there's really no need to show things that pinch out because they just don't. Doing simplified rate transient analysis on the plug and perf well example, we can see a couple things diagnostically in the well performance data that gives us an indication of an ineffective stimulation design. These are not common signatures, I'm not going to say. This isn't characteristic of plug and perf, but this is a good one that I wanted to show of what looks like a poorly effective, a bad frac, I guess, a short frac. In the top left-hand plot, you're looking at linear flow as indicated by a straight line relationship on that glorified square root time plot. But what's happening in the data, which isn't a common behavior, is that the data we're used to it hooking up, you know, but in this case it's hooking down. What could that be? Well, our interpretation is that that is linear flow going into pseudo-radial flow, in the sense that the completion is acting like a choke, that the fracture is not accessing enough of the rock that it needs to, and that there is a rapid transition from linear to pseudo-radial, which can be achieved from a well that doesn't have fractures that extend effectively deeply into the reservoir. And that cartoon can be sort of captured in the bottom right-hand corner there, which is again a very overly simplified understanding of looking at the completion and seeing that the fracs are far apart because of inefficiencies in the stimulation, and of course the onset of pseudo-radial flow around those fracture faces is inevitable with that type of configuration. The type curve analysis work, beyond the simplified analysis that you saw on that dashboard previously, confirms the same thing in terms of efficiencies. The efficiencies are confirmed, and this is the critical part, the efficiencies are confirmed through the permeability constraint that we're using from our confining pressure core analysis results. If we assume that the perm is 100 feet, there's only a certain number of NF, or number of fractures, that can be achieved while creating a suitable history match. And this is what we do to, at a very high level, in a very simple way, arrive at an understanding of of frac efficiency. What we would love to do is connect those to surveillance information like production logging tool, fiber optics tracers, something that gives us an indication of flow proportion so that we can validate these techniques. And we do have some experiences with this, but not a lot. Our interpretation here is that, yeah, there was poor efficiencies across the lateral in this particular example, this being the worst one. The analytical model that we showed here on history matching the plug and perf, this is a more rigorous form of interpretation than the analysis. It gives us a little bit more flexibility and more parameters to play with. We're seeing perms of 100 nanodarcy as our constraint, but once again, as with the case of the analysis, a 50% frac efficiency across the lateral.